In this video here, we're going to be talking about dividing polynomials using the long division method. So before we get into dividing polynomials, just a quick review of how we use long division to divide numbers. Right? So let's say we have 457 over 7, which means 457 divided by 7. Right? So if you recall how to set up long division, whatever your number you're dividing by, which we call the dividend, we usually set up inside the little division house or whatever you want to call it, and then the divisor, the thing we're dividing by, we put on the outside, right? And then we try to divide 7 into not 457 all at once, but we kind of take it one piece at a time. So 7 into 4, well, 7 is too big, right? So 7 does not divide into 4. So then I go to the next thing I have, which is 45. So how many times will 7 go into 45? That's going to be 6 times, right? So I put the 6 up here, and then I multiply. 6 times 7, which gives me 42, and then I subtract, right? And again, here we're just kind of reviewing the algorithm, like the step-by-step process for doing long division. So when we do long division of polynomials, we're going to follow the same process, just with polynomials instead of numbers, right? So I put 7 into 45, I get 6, write that answer up here, multiply 6 times 7, put the 42 down below, subtract, 45 minus 42 equals 3, and then I bring down the 7 from up here, and then I do 7 into 37 and just kind of repeat the process. All right, so 7 goes into 37 5 times. 5 times 7 is going to be 35. And then I subtract 37 minus 35 and I get 2. So I get 65 with a remainder of 2. All right, 7 goes into 457 65 times with 2 left over. All right, now there's a couple ways you could write that. You could write it as the fraction we had here, 457 over 7 equals 65 plus 2 over 7, right? So 457 over 7 is 65 wholes. It goes in there 65 full times, and then plus 2 sevenths left over, right? So that's one way you can write the result of division. The other way you could write it would be 457 equals your divisor, 7 times your quotient, which is 65, plus the remainder of 2, right? 457 equals 7 times 65. What I divided it by, 7, times my answer, my quotient we call it, which is 65, and then plus the remainder. Right? So two different ways that you can show that result of division, plus the way we had up there with that R2. Right? So those are the step-by-step process that we go through to divide numbers. All right? And again, two different ways that we can to write that answer. So when we're dealing with polynomials, right, basically we do the same thing, it's just more complicated a little bit to do the division. So if we have p of x divided by d of x, where p of x and d of x are just two polynomials, right? So one polynomial divided by another, I'm going to go through my same long division algorithm that we have there. It's going to equal q of x, right? Just like 457 divided by 7 equals 65, plus r of x over d of x. Right, plus the remainder 2 over 7, and notice the d of x here, what's in those denominators is the same, right? The 7 down here and the 7 down there. All right, or the other way you can write it, you can say p of x, which we call the dividend, the thing that we're dividing is the dividend, equals the d of x, the divisor, times q of x, the quotient, which is the result of the division, plus r of x, the remainder. And that's how we had it here, right? 457 was equal to 7 times 65, right, what we divided by times the quotient, the answer, and then plus the remainder of 2, right? And generally when we do polynomial long division, this is the way we tend to write out the answers. Actually, no, we tend to write out the answers this way, right? P of x over d of x equals q of x plus r of x over d of x, right? This is one of those things that comes up a little bit in algebra, a little bit in precalculus, but then when you get into calculus 2, there are some problems that you do in calculus 2 where you have to do long division of polynomials, and when you do it in that context, you want to write the answers like this with that extra fraction at the end. It's one of the little tricks you use sometimes in calculus 2 to do a type of problem that we call an integral. Sometimes you have to do polynomial long division in order to kind of rearrange the stuff you have and write it in a different form. Instead of this, write it like this, and then you're able to proceed with your integral problems, right? So it is one of those things that doesn't come up a lot, but it will come up again if you go far enough in math. All right, so quick review of how to divide numbers. This is what it looks like when we do polynomials. I'm going to pause the recording here and erase all this stuff, and then actually do a problem where we divide polynomials using the same general method that we did up here. All right, so the example we've got here, 6x squared minus 26x plus 12 divided by x minus 4. All right, so we have those written as a fraction, But remember, fractions mean division, right? Is the numerator divided by the denominator. So what I'm going to do is set this up like a division problem, just like the one that I had up here before with the numbers. I'm going to set up the same way, right? So my divisor, x minus 4, what I'm dividing by goes outside my little division house, and then the dividend, what I'm actually dividing, or my numerator of my fraction, goes inside that division house there. Right, so x minus 4 dividing into 6x squared minus 26x plus 12. All right, and now we're going to proceed similarly to what we did with those numbers a few minutes ago. All right, now, when you're doing polynomial long division, here's what you always look for. We don't actually try to do x minus 4 into all this stuff. We just look at the first term in our polynomial, in our divisor, and what's outside here, which is the x. Right, so I'm just looking at the x. I'm kind of ignoring the negative 4 for now. That's going to come into play in a minute. But for now, I'm just looking at the x, and I'm just looking at the first term that's in here, the 6x squared. Right, and basically what I need to do is divide 6x squared by x, or another way to think about it is, what do I have to multiply x by to get 6x squared? Well, if it's an x, well, I need to multiply it by 6 to get that 6 there, and I need to multiply the x times x to get x squared. All right, so two ways to think about it. If you think about it, well, if I do 6x squared divided by x, well, then the x's cancel out and I get a 6x, and that's what I put up here. All right, so that's one way to do it. Or, like I just said, I do, well, what do I multiply x by to get 6x squared? It's got to be a 6 and then an x, and that'll give me 6x squared. All right, so that's our first part. The first term in the polynomial outside, what do I multiply it by to get the first term of the polynomial on the inside? Right? And then, just like when we do the long division with numbers, once I get that number up here, I multiply it by what's out front and write that down below. Now here's where that minus 4 comes in. So I do the 6x times the x, which is going to give me 6x squared, and I do 6x times the minus 4, which gives me minus 24x. All right, so when you're figuring out what number to put up here, you only deal with the first term here and the first term here. That's all you look at. But then when you multiply it times all the stuff that's on the outside and write it underneath. And if you're doing things correctly, everything should line up. What I mean by that is, the x squareds are one on top of the other. The x's are on top of each other there. All right, so it's kind of a way you can check to make sure you're doing things correctly. All right, so we multiply this up here times everything up front, write it all down underneath, and then just like when we're dividing with numbers, we subtract. All right, I have to subtract all this stuff over here from the line up above. Right, and notice I put a parentheses around the stuff that I have down below, because when I'm subtracting all this stuff, I need to distribute that negative to everything inside this parentheses. All right, so if you did all this correctly, the first terms here, the 6x squared and the 6x squared, those should be exactly the same thing. Right? When you multiply this, if you don't get the same thing that's up above here, it means you just picked the wrong thing to put up here, and you need to adjust that before you go any further. Right? These two should be exactly the same. So when I distribute that negative, it becomes a negative 6x squared, and this becomes a plus 24x. Right? So I distribute that negative, so that makes that a negative and makes that a plus. Very important. The most common mistake people make is making this first one a negative, but failing to distribute that negative to that second term that's there. It's very important that you do that. Right? It's not just minus 24x, it's minus negative 24x, which makes it a positive 24x. Right? And then when we subtract 6x squared minus 6x squared, that cancels out. Right? Again, if you chose the number up here properly, when you multiplied it, you get the same thing, and then when you subtract, that first term should always cancel out. If it doesn't, then you made a mistake and you need to stop and go back and fix what you did, right? Because something went wrong there. And then I go to my next terms, minus 26x plus 24x, so that adds up to a negative 2x. All right, so I have a negative 26 and now a plus 24. Again, because of that minus and the negative, that makes it a plus. All right, so I come up with a negative 2x, and then, just like when I'm dividing with real numbers, after I do that subtraction, I bring down my next thing. So I bring down that plus 12, so I end up now with a negative 2x plus 12. All right, and then I repeat the process. All right, so I take my first term out here, the x again, and then whatever's left down below, I only look at the first term of that, which is the negative 2x. All right, and then once again, it's, well, I do negative 2x divided by x, and the x's cancel out, so that gives me a minus 2. That's what I write up here. Or another way to think about it is, well, I have an x, I need to make it be negative 2x. What do I have to multiply x by to make it negative 2x? Well, I have to multiply it by negative 2, and so I put that negative 2 up above. All right? And then once I put that -2 up above, and let me erase these arrows here so that things don't get too complicated. All right, once I put that -2 up there, then I do the same thing as before. I multiply the -2 times both of the terms that are outside. So -2 times x is -2x, which once again should be exactly the same as what's up above. And if it's not, stop and choose something different to put up here so that when you multiply it, you do get the exact same thing. And then when I do -2 times -4, I get a +8. Right? Because a negative times a negative is going to give me a +8 there. Right? So another source of mistakes that sometimes people make doing this type of problem is just messing up the positive and negative signs. You got to pay real close attention to the details when you're doing a problem like this. You really have to concentrate and say, well, okay, I'm doing a negative times a negative. I have to make that a +8. But then when you do the subtraction, right? So I subtract this whole thing that I get down here. Well, when I distribute the negative to that -2x, that's going to make it a +2x, and it's going to make that a -8. Right? And the -2x plus 2x, those are going to get canceled out like they always should, right? Every step of the way, that first term should always get canceled. And then the second terms, we have a 12 and a -8. That gives me a 4, right? And there's nothing left here to bring down. And as long as what I'm left with here, the 4, which is a degree of 0, right? It's like an x to the 0 power. As long as that degree is less than the degree of what's out here, which just is an x to the first power, this is x to the 0. So as long as this is less than that degree, then I'm done. And my remainder here is 4. All right. So 6x squared minus 26x plus 12 divided by x minus 4 equals my quotient, 6x minus 2, plus my remainder, 4, over my divisor, x minus 4 again. All right. And that's how we would write the results of that division. All right, so whatever I get up here, that's what we call the quotient. And then my remainder, I put up in the top of the fraction over the original thing that I divided. All right, just like we did earlier with the real numbers. All right, so that's the first example that we have here of dividing polynomials. If you remember how to divide real numbers, you're following the same process, right? So as long as you understand that part where I put this into this, I put the answer up here, I multiply, then I subtract, I bring stuff down, I do it all over again, and you keep going until you've kind of brought everything down and you have nothing left to do. And then just a couple little things. You're only looking at the first term on the outside and only looking at the first term of whatever's left on the inside. You're multiplying, though, times all the stuff on the outside. And then you have to make sure when you subtract that you distribute that negative all the way through so that you don't end up missing anything or having the wrong sign. Like I said, that's the most common mistake, is leaving this as a minus 24x or leaving this as a plus 8x instead of distributing the negative and making it a minus 8. All right, so those are a couple of the little things you have to watch out for. Now, there are a couple other little tricky things that sometimes happen when you're dividing polynomials. So I'm going to do another video where I just do a couple more examples dividing where I kind of point out some of those trickier things. So make sure you check out that video just to see some more examples and kind of go through this process again, and also see some of the things that could show up in your problem that sometimes cause people to make mistakes, right? So make sure you check that one out.